Hi, and welcome to Simon Says. I'm your host Simon from CRC Robotics, and today we'll be explaining a little bit about analog and digital electronics. So let's begin. First of all, in nature, what you will find is always analog signal. So if you have an analog signal, right? Let's say that's some value. I don't know, maybe some kind of value, let's say voltage. And then you have over time, an analog value will take any possible value without any problem. It will always be perfect because it's the reality. However, that's not practical when you're trying. It's not really practical when you're trying to do some electronics or any measurements of stuff. So you need to switch from analog to digital, which is the topic of today. What is digital electronics? So basically, when you have an analog signal, some of the problems that you will find, it's even though it's natural to have them, they are more prone to noises and background noises, and they can't catch anything. They are a little bit more tricky to actually use in real life because their nature makes them a little bit less practical for computer applications and stuff like that. So you need a little bit of help. And human decided to basically create the digital signal. So, digital. If we go back simply, it's the stream of 1 and zeros that mostly you have saw somewhere in the matrix or something similar like that. The way it works is actually, if we go back to any analog signal, is that it will give a value. For example, let's say that this one is 100 and then this one is 110. So it gives values, and you basically take, at fixed interval of times, you take the value. So for example, I'll be drawing some of them, but you can imagine that it goes way faster. And then you take some points. So each time you take a point, you have a value that is discrete. You don't, like, say 3.75, a lot of digits. You will fix them at basically a given amount of numbers, and hence you have a finite amount of states that you represent with 1 and zeros in binary system. So when you do electronics, what happens is that the 1 and 0 means the presence or simply absence of current, which is why it's called digital. It's mostly logic. It's not like the natural feel. It's really that. So we've covered one thing. If we go back basically to what is digital afterwards, let's put some definition. First of all, let's say that a 1 is 5 volts, okay? So that's a 1. Then there's the 0 over there, at 0 volts, obviously. And then there's a dead gap, which is neither 1 or 0. Why did we put a dead gap over there? Well, let's say that your digital signal is not actually perfect 0 and perfect 1. Well, it's not perfect 0 and perfect 5 volts, sorry. So you're having some noises that you catch from the environment or anything, but it's still within the level for 1 or within the level of a 0, right? So hence you're protected from that noise. That's the first thing. Obviously, someone could say that, I wanna, for each signal that I'm sending, well, instead of dividing it in 2, well, I could divide it in, I don't know. Let's put it, I don't know. Like, let's divide it in 3. So like so. And then you have at 2.5 volts, another symbol. So you have, like, say, I don't know, -1, 0, and then 1, or something similar than that. And you have your, once again, your dead band. What happens if you divide it more and more and more, then you come back to the analog and you're more prone to noises. So there will be problems into the transmission, and it's not necessarily what you want. So mostly what you will see when you're doing beginners digital circuit is actually 0, 5 volts, 0 and 1, or sometimes you'll also have, instead of 5 volts, it will be 3.3 volts. But the idea is that you have symbols, single symbols, and it's pretty fine like that for most application actually. So that's the first thing. You quantize the value, and then that's for like 1 bit. And then you can put streams of bits to represent one value from your analog signal. So for example, I don't know, let's say that on some random signal, like so, then we say this value over there correspond to, I don't know, let's say 4, okay? So 4 in basically in binary number would be 1, 0, 0. So you send those 3 bits and it represents that value. So the more bits, for example, if I was on an 8-bit register, so I can send 8 bits of data for each point, then the value will be 1, 2, 3, 4, 5 zeros, 1, 0, 0. So I have all this information to basically quantize my system. So that's one thing. Then what happened is that, so for each signal you send 8 bytes. The second aspect I was talking about is basically once you got your signal for 1, the other aspect that is important is your sampling frequency, or how much digital that you take for each step. So for example, if let's say that this is 0 second, 1 second, 2 seconds. If I sample at 1 Hertz, which means 1 time per second, then I'll be sampling over there, over there, over there. If I go at 2 Hertz, which is 2 times per second, then I will be over there, and so on and so forth. And the faster you go, the more points you have. For example, computer runs at 3 point something gigahertz, which is 10 to the 9 hertz, which is really, really fast. So they can process all those bytes really, really quickly and do a lot of stuff with it. The last thing so if you were to see, for example, I'm sending transmission, well, it will look something like that. So you have over time, once again, this is the time, this is the voltage. Then you would send, like, for example, here's a 1, this is 5 volts over there and 0 volt, this is a 1, and then, oh, absence of anything, there's a 0, and then we could put 2 more, basically, 2 more 1s. Like so. In conclusion, what we learned from this small video is that 1, analog is nature. 2, digital is for a computer to be used. So, in order to use computer, you need at some point to digital anything, be it MP3 players, be it videos or something. If you want to use it with your computer, it needs to be digitalized. Any observation whatsoever, it could be a magnetic field, it could be a color, whatever, you need to digitalize it. And to finish this article, basically, I'll draw a small schematics to explain a little bit how it's done. So, you have your, we'll call it your analog phenomena, which is basically what you want to study. Then you have some kind of sensor, transducer, microphone, camera, anything that can digitalize it. And then finally, and here your analog your like analog something. This will give you an analog voltage. And then you have the final step is an analog to digital converter, or ADC. And once you're out of the ADC, you're in the marvelous digital world. I hope you like the video. If you have any questions, don't hesitate to ask them in the comment section. And have a nice day.